Hey everyone, welcome back to my Calculus 2 series. In today's lesson, we're going to start off by talking about differential equations. Firstly, this lesson is going to be a lot about the theory of what differential equations are, and kind of just a brief introduction to it, because differential equations can get very in-depth. There's entire courses dedicated to differential equations, so we'll kind of just be scratching the surface with this stuff. So firstly, a differential equation is an equation that contains an unknown function and one or more of its derivatives. Another important term to define would be the order of a differential equation. And basically the order of a differential equation is just the order of the highest derivative that occurs within an equation. So if within that equation we see a derivative like the third derivative of something, and that's the highest derivative, well then that's the order of the entire differential equation. So yeah, all we want to do is just find the maximum or the highest derivative within that equation, and then we call that the order of the differential equation. Now, just to give you a quick example of what these look like, so a differential equation something in the form of this, perhaps. It could look something like this. So as you could see, we have this derivative, and then we also have a bunch of these other functions, right? And in this case, it's kind of obvious that y is going to be a function of x. So unlike what we've kind of been introduced to previously in our mathematical careers, usually the answer to an equation would be like, I don't know, maybe it's x and y coordinates, maybe it's just a value or something, but in this case, a solution to a differential equation is a function, but more specifically, it's a family of functions. And I'll kind of show you in the next example why that is so. But it's important to know that if we want to solve just for the general solution of a differential equation, it's going to be a whole family of functions. And basically, a function f is called the solution of a differential equation if the equation, the differential equation, something like this, would be satisfied when y is equal to that function. So we've already seen some very, very simple differential equations, and we've solved them, particularly with the integrals, right? If we were given something like, okay, y prime is equal to, I don't know, x cubed, right? Well, the solution to this right here, well, that would just be y is equal to x to the 4 over 4 plus c, right? So these are very, very simple differential equations. We'll kind of see in the next chapters how we can solve a little more complex ones, but you can kind of get the gist that the solution to a differential equation is going to be a whole family of functions, as we could see with this constant c right here. So here is a quick little example. There's not going to be much computation done here. It's more like just let's kind of start thinking about differential equations and how to solve them and stuff. So the example would be that, okay, if we have the derivative of p with respect to t, well, that's going to equal to k times the function p itself, right? So now let's think of a function whose derivative is a constant multiple of itself, right? Well, the first function that should pop in your head is e to the x, right? The derivative of e to the x is, well, it's just itself. And then if we want to have a constant in front of it, well, maybe we throw a k up there, right? And then now the derivative of this, well, that would just be k to the x. E to the x is used pretty often. So for the solution for this differential equation, we're going to be solving it using something like this. So we can sort of rewrite this as saying, okay, well, p prime of t is equal to kp. Just maybe for visual purposes, this is a little bit easier to see. Or actually, I'm just going to get rid of this right here. So we're just going to write that p prime is equal to kp. So now that we have kind of figured out a function whose derivative is a constant multiple of itself, I'm going to propose that we say that p of t is equal to c times e to the kt, right? Where k and c are both constants. So now if we were to take the derivative of this, right, well, p prime of t is going to equal to ck e k t, right? And then we can kind of go on to, you can kind of see already how the function itself reappears already, but if that's not evident, I'm just going to factor out a k from here, and then we'll make this a square bracket so you don't get confused. CEKT, And now you can clearly see that the function has reappeared again. However, this factor of k is out here. So indeed, this is equal to k times p. So there we go. We have found a function right here that is going to be a solution for this differential equation. However, we have found not just a function, we have found a family of functions because of these constants right here. And the graph of them will look something like this. So what's important to pull from this example is that the solution to a differential equation is going to be a family of functions. Now I'm going to introduce you to initial value problems, and we won't be solving any here, but it will definitely come up in the later lessons. So generally when we're solving these differential equations, we don't want to find these families of functions. What we want is specifically a solution that will satisfy the differential equation and some additional property. So a big giveaway that we're on an initial value problem is that we have an additional property to fulfill. A lot of the initial value problems, especially in physics, they'll have some condition that says, okay, well, y of some x value, in this case it's labeled t0, that's going to equal to some value y0. And this essentially is kind of like a coordinate. You can almost think of it as a coordinate that's given to you, and we want to find the function that flows through that coordinate. So these are called initial value problems. Basically, when we have this initial condition, this if we're given something like this is called an initial condition. So if we are given an initial condition, then we have an initial value problem. And again, later on we will see how to solve these. But yeah, it's just important to realize that with an initial value problem, now we're only looking for one function that satisfies both this initial property and the differential equation itself. So that's it for this quick little introduction to differential equations. Hopefully you've enjoyed it and learned something. If this video has helped you out at all, please leave a like and comment as to what it helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I'll catch you guys in another video.